just finished learning how to factor. So right now I'm going to show you what we're going to use the factoring for. First off, we use factoring in order to help us to solve higher order equations. So not just a simple linear equation like we've done in a beginning algebra class. So for solving, the first thing that we need to know is called the zero product property. It says to solve equations, we often use the zero product property, which states that if the product of two numbers or expressions is zero, then at least one of the numbers or expressions must equal zero. And concisely stated here, it says for all real numbers a and b, if a, b, remember when they're right next to each other like that, it means that they're being multiplied. If a times b equals 0, that must mean that either a equals 0 or b equals 0 or both. We're going to use this property, which seems like a kind of a common sense property, and we're going to use it to solve some quadratic equations. If we use the zero product property for this equation, this is our a, and this is our b. So we have two expressions, a and b, and they're being multiplied together. They equal 0. So we know that we can use the zero product property. First of all, we have a 0 on one side, and we have a product. A product means the result of multiplication. So it says that if a times b equals 0, then either a equals 0 or b equals 0. So that must mean that 2x equals 0 or x plus 8 equals 0. And then we can solve each of those equations separately. Here we'll divide by 2. Remember, the 2 is attached to the x by multiplication, so we're going to get rid of it by dividing. So we get x equals 0 divided by 2 is 0. Or over here we have x plus 8 is 0, so to get rid of that 8, we're going to subtract it off. We have to do both sides, so we get x equals negative 8. So we have actually two solutions to this equation, and we found them by using the zero product property. Let's try that zero product property with this one. Okay, we can say that this is our a and that this is our b. So a times b equals 0. We have a product equaling 0, so we can use the zero product property. That means 6z plus 5 equals 0, or z minus 7 equals 0. So I'm going to solve both of those equations just the way I've done in my beginning algebra class. So I'm going to subtract 5 from both sides to get rid of that 5. That gives me 6z equals negative 5. And how would I get rid of that 6 that's with the z? Remember that it's attached by multiplication. It's 6 times z. So to get rid of it, we divide. So z equals negative 5, 6. And we'll come back and work on this one too. So to get rid of that minus 7, we'll add 7. And that gives me z equals 7. Again, we have two solutions for one equation, something that we haven't encountered before. All right, I'm going to give you a formal step-by-step process for solving quadratic equations. To solve a quadratic equation by factoring, follow these steps. Step 1, if necessary, write the equation in standard form as ax squared plus bx plus c equals 0. Okay, so that means that we have everything on one side equal to 0, and our exponents are descending. We have an x squared, we have an x with no exponents, and then we have a term with no x's called the constant term. Step 2, we want to factor the left side of the equation using any method. So we would factor this polynomial using any of the factoring techniques that we learned in the chapter 6. Step 3 is apply the zero product property. That means if A times B equals 0, then A equals 0 or B equals 0. Step 4, we'll solve each of the resulting equations, those two simpler equations that come from the zero product property, and then we'll check our solutions. Okay. So just as we do anything, if we go through here and one of the steps is already automatically done for us, then you would just skip it. Okay, no problem. Okay, let's say that we want to solve and check this. If necessary, write the equation in standard form. And this is in standard form. Everything is on one side equal to 0, and our exponents are descending. We have a z squared and we have a z to the first power. Step 2 is factor the left side of the equation using any method. So I'm looking at that, and something should kind of catch your eye there, catch your attention. There's a greatest common factor. Remember, that's the first thing you always look for when you're factoring. Look for a greatest common factor. So we'll take out a 3z, and 3z times what is 6z squared, and that would be a 2z. Or you can think of it the other way by dividing. 6z squared divided by 3z is 2z. And then I have a negative divided by a positive, so it's going to be negative. 3z divided by 3z is 1 equals 0. Okay, it's imperative that we factor this first before we use the zero product property. Remember, the zero product property is more than just getting a 0 on one side. We have to make this a product. The way we make it a product, the result of a multiplication, is by factoring it. Factoring shows multiplication. Now we can use the zero product property. If both of those multiplied together equals 0, that must mean that 3z equals 0 or 2z minus 1 equals 0. And now we'll solve each of those simpler equations. So here I'm going to divide by 3, and I get z equals 0. And over here, I need to first add 1 to both sides to get the term that has a variable in it by itself. And to completely get that variable by itself, I'm going to divide by 2. So z equals 1/2. Now we're going to check, the directions say check, and it's always a good idea to check our solutions and make sure that we haven't made a mistake. So we're going to check each of them separately. First, I'm going to check z equaling 0. Does that actually make sense? 6, we'll put it back into the original. 6 times 0 squared minus 3 times 0 equals 0. So 0 squared is 0, times 6 is 0, minus 3 times 0 is 0, equals 0. And yes, that is true. So z equals 0 is correct. And I'll check over here my z equals 1/2. So if we try that, we have, let's see, 6 times 1/2 squared minus 3 times 1/2 equals 0. Remember, we're putting it into the very original problem. And we'll go from there. 6 times 1/2 squared is 1/4 minus 3 times 1/2 is 3/2 equals 0. And now I have 6 times 1/4. That's 6/4 or 3/2 minus 3/2 equals 0. And yes, that does check. So we have our second solution is also correct. Z equals 1/2. Let's try that same process with this. The first thing was to get this in standard form, and it is in standard form. The second step is to factor. So I'm going to factor this. Remember, go through your factoring steps that we had an outline of. This factors as a difference of squares as 2n plus 1 and 2n minus 1. Alright, now we can use the zero product property because we have a 0 on one side and we have a product, a result of multiplication. So 2n plus 1 equals 0, or 2n minus 1 equals 0. Then we'll solve each of those separately. We're going to subtract 1 here. So I get 2n equals negative 1, and then I'll divide by 2. So n equals a negative 1/2. Or over here, I would add 1 to both sides and get 2n equals 1. Then I would divide both sides by 2 and get n equals 1/2. Again, we're going to check these. Check both solutions. Check n equals negative 1/2 and put it into the very original problem. 4 times a negative 1/2 squared minus 1 equals 0. So 4 times, remember we do exponents first and then we'll multiply by the 4. So a negative 1/2 squared is 1/4. And 4 times 1/4 is 1 minus 1 equals 0. So 0 equals 0. Then we'll check n equals 1/2. Again, put it into the very original problem. Always want to do that. And we get 4 times 1/2 squared is 1/4. Minus 1 equals 0. So I get 1 minus 1 equals 0. 0 equals 0. I get true statements on both of those. So that means both of these answers work as solutions. Moving on, let's try a trinomial here. Let's see if we can factor this. First of all, it's in standard form, all in descending order, everything on one side equal to 0, so we're ready to factor. So let's go ahead and break this up. I know there's no greatest common factor, but I can go ahead and write my parentheses. And let's break up the 6 as 2y and 3y. Let's see how we get with that. And the 10, let's break that up as 5 and 2. And plus and plus. Let's see if that checks out. 5 times 3y is 15y. 2y times 2 is 4y. And if I add 15y and 4y together, I get 19y. So this is how that factors, just real quickly. And I get 2y plus 5 equals 0, or 3y plus 2 equals 0, because we have the zero product property. We have a 0 on one side and we have a product over here. So I'm going to subtract 5 from both sides here. I get 2y equals negative 5, and divide by 2. Y is negative 5/2. I'm going to subtract 2 here, and get 3y is negative 2, and then divide both sides by 3, get y equals a negative 2/3. Okay, let's check both of those solutions. We're going to check y equals negative 5/2 right here. And remember, put it into the very original problem. 6 times negative 5/2 squared plus 19 times negative 5/2 plus 10 equals 0. And if you'd like, you can use your calculator on this to make it just a little quicker. So we would say 6 times parentheses negative 5/2 parentheses squared plus 19 times parentheses negative 5/2 close parentheses plus 10. And when we hit enter, it should equal 0 if we have it correct. And it is, so we know that that is correct. Okay? And let's check y equals negative 2/3. Again, put it into the very original problem, 6 times negative 2/3 quantity squared plus 19 times negative 2/3 plus 10 equals 0. And we'll put that into the calculator. In fact, if you want, you can go hit the second button and hit entry. It puts the same thing in as you had before, and then you can scroll back and just change the numbers a bit. So this was to be a 2/3, so negative 2/3, and this is to be a negative 2/3, and then hit enter. Again, it equals 0, and that's what we want. We want that to equal 0 for this problem. So we have it. That checks as well, and that means that both of our solutions are correct. We didn't make any mistakes. If you have a problem where it does not check, it means you must have made a mistake over here in either factoring it, or after your factoring has been completed, you've made a mistake in solving the simple equations that follow. So you would want to go back and check to see what kind of mistake you made. Well, let's try this one. This is a little bit different. How does this one look different from the last few problems that we've done? Well, one thing is that it doesn't have a 0 on one side for you already. You're going to have to do that. Remember what the steps said. The steps said, number 1, if necessary, write the equation in standard form. So we need to have a 0 on one side because we're heading towards using the 0 product rule. So we need to get a 0. How can we get a 0 on one side? And quite simply, we could do it by subtracting 5t from both sides. So we'll take t squared, we'll subtract 5t equals, and then 5t minus 5t is 0. Now the next step is we have a 0. We have to get a product, so we can use the 0 product rule. So we have the 0. We need to make this a product. Okay, so we need to factor. We're going to take out a t. That's our greatest common factor out of both of those. And what are we left with? We're left with a t minus 5. And that equals 0 still. And now the 0 product property says if this times this equals 0, then either the first thing equals 0 or the second thing equals 0 or both. So t equals 0, that's already solved for us. And this one we add 5 to both sides, so we get t equals 5. And we're going to check t equals 0 and put it back into the original equation. 0 squared equals 5 times 0. 0 squared is 0. 5 times 0 is 0. That checks. So I know for sure that that is a correct solution. And now I'm going to check t equals positive 5. Okay. And put the 5 back in. 5 squared equals 5 times 5. 5 squared is 25 equals 5 times 5 is 25. That checks. So this is also a solution. Okay, so just a little tougher problem than the few that we've done before this one. Okay, now this one looks a little tempting. It looks like we have a product already, and but that's not a 0. Remember that we're using the 0 product rule, or the 0 product property. Okay, so the first thing that we want to get is a 0. We need to have a 0 on that one side. So we're going to subtract 3. X times 2x plus 5. We're going to subtract 3 from both sides. And now we have the 0. Now we need to go to getting a product. And the problem is, this looks like, hey, it looks like this part is factored. But the point is, the entire thing is not factored. if only a part of it is, then it doesn't really help us. We need to make sure that we factor the entire thing, which means even though this looks nice and factored here, we're going to have to go ahead and multiply it out to get rid of this kind of a mess here. Okay, remember it's in descending orders, it's in standard form, and now we're ready to factor it. We're going to factor the whole thing. So the 2x squared, let's break up as 2x and x. And the 3, let's break up it as 1 and 3. Put a plus here, minus there, so we can get the minus. And let's check the middle term. 2x times 3 is 6x. And a negative 1 times x is negative 1x. And we take 6x, subtract 1x, we get 5x. So this is the factorization of that trinomial. And let's go ahead and use the zero product rule now, because we have a 0 and we have the left side is a product. The entire left side is a product. So that means 2x minus 1 equals 0, or x plus 3 equals 0. So 2x equals 1, x equals 1/2, x equals negative 3. Okay, so these should be our solutions. Let's go ahead and check. And you can tell I've been skipping a few steps as we go. You are welcome to do that. You don't need to show subtracting 3 from both sides. You don't need to add 1 to both sides and show that you're dividing by 2. You can just go through as you know how to do these problems. This is previous material. Okay, we're going to check the x equals 1/2, put it into the very original problem. I have 1/2 times 2 times 1/2 plus 5 equals 3. Okay, when we have nested parentheses, we have this set of parentheses and we have this other set of parentheses nested inside there. We need to do what's on the inside, the inner set of parentheses first. So 2 times 1/2, we'll go ahead and do that. 2 times 1/2 is 1. Plus 5, and write everything else as it was. The only thing that's changed is that 2 times 1/2 has turned into a 1. Then I have 1/2 times 6 equals 3, and half of 6 is 3, isn't it? So that means that our x equals 1/2 does work. And let's check our x equals negative 3. Put into the very original problem, negative 3 times 2 times negative 3 plus 5 equals 3. And I get negative 3 times negative 6 plus 5 equals 3. Negative 6 plus 5 is negative 1. Write everything else as we go, just as it was before in the step before. So negative 3 times negative 1 is a positive 3. So x equals negative 3 is also a solution. Okay. Now, we use this in applications a lot. So we'll start using this product throughout the whole course in solving different kinds of applications. It'll show up a lot. So you'll want to make sure that you learn it not just for this material, but for the next material. For the applications, let's first start with this one. We have the dimensions of a square. It says that a square has an area of 144 square feet. Find the length of a side. All right, so let's draw a picture. Pictures always help when we're doing these application problems like this. So remember that a square is defined that all the sides are of equal length and the 4 angles are 90-degree angles. So this square has an area of 144 square feet. Find the length of the side. Now the thing that they're asking you to find most often is the thing that you're going to let your variable be. So it's saying find the length of a side. So we're going to let x equal the length of a side. Let's draw that in. there's a side, there's a side, there's a side, there's a side. Go back and read the problem again. A square has an area of 144 square feet. So here, let's see. If they're saying something about area, we should probably use an area formula. So if you would look on the back fly page of your book, you'll see that page is all the formulas for different geometrical shapes. So if you have a question about what formula to use, you can always go back there and check that as a reference. But the area of a square is the length of a side squared. That's the area. Okay? So we're using this formula and we're going to put in what we know. What is the length of the side? It's x, and we have to square that. And what is the area? It says the area is 144 square feet, so we're going to put 144 in for our A. Now we have to solve this, okay? Now it's a quadratic, has a square right there, so that tells you right there, you're going to have to use a zero product property. So remember, the first thing to do is to get a zero. We're going to subtract 144 from both sides. So if I do that, I get a 0 here, and minus 144 there, like so. And now I need to factor this. So 0 equals, looks like a difference of squares to me, an x and an x, a 12 and a 12, and a plus and a minus. Now we have a product, we have a 0, we have a product, so now we're ready to use the zero product rule. It says x plus 12 equals 0, or x minus 12 equals 0. So here, subtract 12 from both sides, we get x equals negative 12, or add 12 to both sides, we get x equals positive 12. Okay, so if we would check these, they would both check and everything would be great, except that this is an application of a real-life object here. And this is supposed to be the length of a side. X is representing the length of a side. So it's okay for the length of a side to be 12, but it doesn't make sense to have a negative length. Okay, so we're going to throw this out, not because it doesn't check, but because it doesn't make sense in the context of this problem. And we'll keep this answer. And we need to make sure and state our answer with the unit. So if the area was square feet, then the length of the side is 12 inches. Oh. Is 12 feet. Okay? And that's it for that application. All right, set up an appropriate equation for this scenario. Do not solve, but describe how you would solve it after setting up the equation. All right, this is a picture frame and it's 4 inches wider than it's tall. So let's go ahead and start drawing. Okay, there's our rectangular picture frame. It's 4 inches wider than it is tall. The area of the frame is 24 square inches. What are the dimensions of the frame? Okay, we have two things going on here. We don't have just the length of a side like we had last time, where all the sides are the same. We have different sides. So in that case, we always let x equal the thing that we know the least about. We're going to let x equal, let's see, the picture frame is 4 inches wider than it is tall. We know something about the width. It's 4 inches wider than it is tall. Do we know how tall it is? We don't know anything about how tall it is. So we're going to let x equal, let's say, the height of the frame. Okay, and that means what is the width of the frame? Well, if the height of the frame is x and the picture frame is 4 inches wider than that, then it'd be x plus 4 more inches. It's 4 inches wider than it is tall. Then it says that the area of the frame is 24 square inches. What are the dimensions of the frame? That must mean that we're going to have to use the area formula for rectangles. Can't use the same formula as we did with squares because the sides are not guaranteed to be equal. So we're going to go ahead and find the area of a rectangle is length times width. Again, that's on your back fly page of your book, or you can also look it up in the ebook. So the area we know is 24. Okay, and the length or the height is x, and the width is x plus 4. Okay. And it says do not solve, but describe how you would solve it after setting up the equation. We did set it up. It's perfect. Now, if we're going to solve this, I might multiply this out. I get x times x is x squared. That tells me I'm going to have to use the zero product property. So I'm going to have to get a 0 on one side. I need to multiply this out and get everything put together with like terms, and then factor that entire side. After you've factored that entire side, then you'll set each of those factors equal to 0 and solve those two simpler equations. And of course, you're probably most likely going to get an answer that doesn't make sense here because this is a physical application. So you would throw that nonsensical answer out and keep the one that does make sense. Remember to get your units there as inches. So we'd say the height of the frame is whatever inches, and the width of the frame is whatever inches. The Pythagorean theorem is something that you may have seen before. If you don't remember it, remember you can get it from the back fly page of your text. And the Pythagorean theorem is a theorem that's used with right triangles. That means that it's a triangle with one angle that is 90 degrees. A and B represent the legs of that triangle, the length of the legs, and C is always the hypotenuse. Okay, so those are legs, and this is always the hypotenuse. All right, now we're going to use the Pythagorean theorem to find the value of x in the figure here. Okay, a little different here. I have a squared plus b squared equals c squared. Let's see what we can do. A is the length of one of the legs, so it's x minus 1. But I have to square it. If I want to square that entire x minus 1, I'm going to need to put that in parentheses. Plus b squared, let's call this b, that's an x squared, equals c squared, the c is the hypotenuse, so we'll put x plus 1, and again, if I want to square that entire length, I need to put parentheses there. So we have set it up, now we just need to solve this. So let's go ahead and multiply this out. I have x squared minus 2x plus 1 plus my x squared equals x plus 1 quantity squared is x squared plus 2x plus 1. Okay. If you can't remember how to expand those binomials, then you may want to go back and look at some of the material out of Chapter 5. All those chapters are still accessible to you in the ebook. All right, let's go ahead and proceed from here. I have a quadratic equation. That means I'm going to have to use the zero product property or the zero product rule. So let's go ahead and combine some like terms. I have x squared and x squared is 2x squared minus 2x plus 1. That's all on the left side. The right side doesn't change any. Okay. Now, if I'm using the zero product rule, then I need to get a 0 on one side. I need to get this side to be 0. So I'm going to subtract x squared. Okay. And I'm going to subtract 2x. And I'm going to subtract 1. So I get a 2x squared minus x squared is just a 1x squared. Negative 2x minus 2x is minus 4x. And a 1 minus 1 is gone, just 0. Equals, everything on this side has gone away. So we have the 0. Now we need to get this to be a product, and we get that to be a product by factoring. Remember, greatest common factor. And that is completely factored. So we set each factor equal to 0 and solve. This one is quite simply solved, and this one we need to add 4 to both sides, and we get a 4. Okay, now let's check and see which of these works. Maybe both work, maybe neither one of them work. Would 0 work here? 0 minus 1. That would mean that this length is a negative 1. That doesn't make sense, so I'm just going to throw that out right away. X equals 4. 4 minus 1 is 3. And 4 plus 1 is 5. And x is 4. All the lengths are positive, and we can check this putting it into the Pythagorean theorem. So if this is 4 minus 1 is 3. This is 4. And 4 plus 1 is 5. I can put that into the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. So that's 9 plus 16 equals 25. And that's true. So the value of x in the figure is 4. Remember, it asks us to find the value of x in the figure. The flight of a baseball. We have the height and feet of a baseball after t seconds given by h equals negative 16t squared plus 88t plus 3. At what values of t is the height of the baseball 75 feet? Okay, so they've given us this formula for the height of the baseball. So h is negative 16t squared plus 88t plus 3. And what else did they give us? At what values of t is the height of the baseball 75 feet? So they're saying that the height is 75 feet. We can replace our h with 75. So 75 equals negative 16t squared plus 88t plus 3. Now if I solve this, I bet I can find those values of t when the height of the baseball is 75 feet. So I see that we have a quadratic equation. I know that because it has a square on the variable. It means I'm going to use the zero product rule. Every time you have a quadratic that you have to solve, then it's zero product rule. That means I'm going to get everything on one side equal to 0, so I can get the 0 from the zero product rule. That means I'll add 16t squared, subtract 88t, and subtract 3 on both sides. So on this side I get a 16t squared, a minus 88t, and a plus 72 equals, and everything on this side canceled out. I get a 0. So now I want to solve this. Can I simplify this any at all? And if we can do that, then we definitely want to do that to make the rest of the problem easier. We have a greatest common factor of 8. So I'm going to take 8 out. And what am I left with? I have a 2t squared minus 11t plus 9. And remember, that's all equal to 0. So we'll factor from there. And make your 2 sets of parentheses. And we'll break 2t squared up as 2t and 1t. And let's try a 9 and a 1, and they'll have to both be minus. That gives me a 2t, negative 2t. and a negative 9t makes a negative 11t. So now I have three factors that equal 0, and we can still use the zero product rule. So this factor equals 0, or this factor equals 0, or this factor equals 0. Okay, and 8 equals 0 does not make any sense, so we throw that out. And this one, let's see, 2t equals 9, and t equals 9/2. Or this one, t equals 1. So it looks like, as far as time, we're doing seconds, looks like after 4.5 seconds, and at 1 second, then the height of the ball has reached 75 feet. Alright, you should be able to do that section of homework then, and be sure and email me if you have any questions.